All right, welcome everyone. Today we are diving into a really critical topic, intellectual property theft, specifically through what's known as model extraction. Now this is part 3 of a 5-part tutorial from Virtualization Options LLC, and just a heads up, it's for educational purposes only.
And before we really get into the weeds, I do want to mention that this is a summary. For the full deep dive experience, you'll definitely want to check out the detailed course document in PDF format. It has way more detail than we can possibly cover here.
So I want you to think about this for a second. In today's world, a company's most valuable asset is often its AI model. It's literally the company's brain. So what happens when corporate spies don't need to pick locks or bribe insiders? What if they can steal that brain just by asking it questions?
Okay, let's get into it. In our previous explainers, we talked a lot about personal data leaks and privacy, but this is a whole different ballgame. We're talking about an existential threat to a company, the outright theft of its core intellectual property, the very thing that gives it an edge.
The main weapon here is something called a model extraction attack. Now, this isn't your classic hack. Nobody's breaking into a server or stealing source code. Instead, attackers just systematically query the AI through its public door, the API, over and over again until they've gathered enough information to build their own functionally identical clone. It's kind of like figuring out a secret recipe just by tasting the finished cake thousands of times. So to see how this works in the real world, let's dive into our first case study. Think of this as a high-stakes digital heist, with the target being a major player in the autonomous vehicle industry. The estimated value of the IP that was stolen? A jaw-dropping $250 million. And we're not just talking about lines of code. That number represents years of painstaking research, development, and a massive competitive advantage just gone. But honestly, the money isn't even the worst part. The real strategic blow was this. The thieves saved themselves 18 months of development time. In the cutthroat race to build self-driving cars, 18 months isn't just a head start. It's a potential game ender for the company that got hit.
And here is the truly shocking part. The model they cloned, it achieved 94% fidelity to the original. This wasn't some cheap knockoff. This was a near-perfect replica of the victim's most precious technology, and it was built without ever touching their internal systems.
So, how in the world did they pull this off? Well, it was a beautifully methodical 4-step operation. First, they launched a distributed attack from over 2,400 different IP addresses to stay under the radar. Sneaky. Then, they started reverse engineering the model structure, just by analyzing its response times. After that, they painstakingly mapped out how the AI makes decisions, when to brake, when to change lanes, and finally, with all that data, they just trained their own substitute model. A perfect clone.
Now, our next case study takes things even a step further. The target this time was a precision electronics manufacturer, and the attackers, well, they didn't just steal one thing, they hit the absolute jackpot.
And this is what makes this attack so incredibly clever and so dangerous. See, the attackers went after an AI that was designed to spot tiny defects in semiconductors. So by stealing the AI, they got the tool, which was valuable enough. But because that tool was trained on images of secret, unreleased chip designs, they also got the blueprints. A 2-for-1 theft.
And you can see, this was no quick smash and grab. They were patient. Over several months, they mapped the API, built their attack, and then just methodically pulled out thousands of proprietary designs. And the victim? They only found out about it when their rivals suddenly started filing patents using their own stolen work. Ouch.
Okay, our final case study here involves a SaaS company whose entire core product was stolen by what you can only really call a ghost army of digital users. And they did it by completely sidestepping the company's security. Before anyone even knew what was happening, this ghost army had already hammered the company's AI with over 4.2 million queries. It was this massive, coordinated effort that just flew completely under the radar.
And the result? They built a clone of the company's proprietary natural language processing model that was 92% accurate. And sure enough, shortly after, a competitor launched a service that was, well, nearly identical, pretty much gutting the original company's market share. So how did this ghost army stay so invisible? It was a really sophisticated setup.
They created almost 850 user accounts that looked totally legitimate. They hid their tracks using proxy networks in over 60 countries, and they were smart about it. They automated their queries to look just like real human behavior, making sure every single account stayed below the daily API call limit. By spreading the load like that, their huge campaign was basically invisible.
So this really drives home a crucial point. Basic security measures, like per-user rate limits, they're just not going to cut it anymore. A determined attacker with enough resources can just assemble one of these distributed ghost armies and make those simple defenses totally irrelevant.
So, you might be thinking these attacks are just random, chaotic events, but they're not. There's actually a clear playbook that attackers follow, which turns these digital heists into a predictable and even a quantifiable process.
This table here basically lays out the price of the heist in terms of queries. And it shows that how much effort you need depends entirely on how complex the AI model is. A simple model, you might clone it with a couple 100,000 queries. But a really complex computer vision model, you're going to need millions. It really all boils down to a numbers game.
So what does all this data actually tell us? Well, for an attacker, the first gains are cheap and fast. You can get a pretty good 60–70% copy of a model relatively quickly. But getting that last 10% of perfection gets exponentially harder and more expensive. And for the defenders out there, this is so important. If your API gives away too much info, like detailed confidence scores, you are literally making the attacker's job easier and cheaper.
So, what's the big takeaway here? Model extraction is not some theoretical threat you might read about in a white paper. It is a very real and very present danger. We've seen how attackers can clone a company's brain right through the front door, from self-driving cars to microchip designs. Which leaves us with one pretty crucial question. In a world of digital ghost armies, your AI is your competitive edge. Are you absolutely sure it's still only yours?